Hi, I'm Saif, an early engineer at Benchling, an SF-based startup that makes web-based software for life science. I'm also the author of the Perf tooling articles that can be found in the React docs, which were entirely inspired by my work at Benchling. So today I'd like to talk to you about how Benchling used React to build an electronic lab notebook and how we solved the performance issues we ran into while building it. Before we dive into all things performance, I'd like to give you a sense of all of the application we're building by highlighting two of Benchling's products that enable scientists to do their research. The first being our DNA editor, which I first started working on as an intern more than 3 years ago. It allows scientists to explore an organism, plan out changes they'll be making to that organism. And we can see a live demo right over here. So it has a pretty fast frame rate. You can interact with this plasmid. Oops. Scientists will do fancy things like run CRISPR analyses, which is all the rage these days, do restriction digests, figure out how to manipulate their sequence to get what they need done in the lab. This was originally built in Backbone and D3 using SVGs. We spent a lot of time making this fast and even building an infinite scroller on the left side to deal with the performance issues with large sequences. We've toyed with the idea of porting this to React. And after Sarah's SVG animation talk this morning, the prospect seemed more exciting. But then after James Long's refactor talk, I got a little less excited about it. But maybe I'll let you know what happens in the next React rally. The second product that we built was an electronic lab notebook that we built in React about 2 years ago and are still continuing to develop. Sort of similar to Google Docs or Evernote, but more with a scientific focus. So if we look at an entry here, it has a interface for typing. Hello, how are you doing? It's got a little more fancy things that Google Docs doesn't have, like tables with formulas. So you can do, I don't know, average. A to-do list for planning your experiments in the lab, images that you get from doing gel analyses, which in the future will let you annotate. And then finally, linking back to rich data types like our sequences, which you can then open within Benchling and interact with. So our users are scientists who live in our application. They tend to push the boundaries of performance, wanting to edit genomes, large arrays of tabular data, and record lengthy documents detailing their experiments. They're also solving really hard problems, curing diseases, biologically engineering organisms to synthetically manufacture who knows what, and much more. What they do in Benchling translates to physical experiments, so mistakes in rendering can be costly. Accidentally showing Fahrenheit and labeling it Celsius, or on that, the sequence map, accidentally labeling the annotation a few bases off will have drastic effects on people's actual experiments. So React fit really snugly with our needs. It gives us the declarative components for correctness with the baseline performance rendering. So our journey begins in 2014 when many others were also excited about rapidly building powerful UIs using React. But as a young technology just gaining popularity, React didn't really have any good libraries or resources available. So we ended up having to build a lot of things from scratch. And like Adam, we were trying to solve a somewhat classically hard problem of building a performant editor. Not too long after, Adam gave up. So we made plenty of mistakes and ran into plenty of performance issues, like Adam did. And for Adam, they decided that the abstractions that React provided just weren't good enough. They were still too costly, and they decided to build it from scratch. We decided to stick through with React, believing that the community would help foster the framework to get stronger and get faster, and also try to solve the performance issues ourselves. Before we actually get into the nitty-gritty details of making our application performant, we need to have a sense of what amount of performance we need in our application. Typically, if you Google around and say, how fast should my application run, they'll say 60 frames per second. This is sort of misleading because typically this refers to games. Every 60th of a second, there's new content coming, a bad guy's running at you, and you need to see them. In a web-based application, a lot of the times, the interactions users are doing aren't actually that frequent. More or less, they're interacting with their mouse, and they're typing with their keyboard. When you're interacting with your mouse, you're doing things like dragging content or scrolling. And you know what? The browser actually does a really good job at doing both of these things, making selections, scrolling your page. If you don't do anything out of the box, the browser is pretty great. I would say you only really run into problems in React when you try updating state while scrolling or mouse moving or dragging, in which case the traditional wisdom of using request animation frame comes into play, and you're fine. But when it comes to typing, no one's actually typing at 60 frames per second. It's, even when you're button mashing, you'll probably only hit like 30 to 40 frames per second. I am not ashamed to say that I type about 12 frames per second. And so if I use an application that only had 20 frames per second in the whole application, I wouldn't mind because I actually wouldn't notice. So keep in mind, when building an input-heavy application, you don't have to achieve this gold standard because it's overkill. Now that you have a sense of what we're trying to build, a performant text editor that allows embedding a variety of rich data types, let's dive into the nitty-gritty details of performance engineering. This is probably going to be a review for some of you, but I'm going to cover how React works a little bit and what perf issues arise because of that. They'll then cover some of the tools at your disposal for actually dealing with those perf issues. And finally, I'll cover how to fix them, how to prevent them, and how to detect those inevitable regressions that your test just couldn't catch. So there are a few levels of abstraction at play here. So as you all know, the browser uses this thing called the DOM, which is the document object model. It provides a JavaScript API for manipulating it, which is really what you see on the screen. Empirically, this is a slow thing. I've allocated it $3. The units are sort of relative. Next, where React comes in is that because of its declarative interface, it needs to do something smart. You can't just say, oh, just rewrite everything in the DOM, because you'll hit the $3 signs. So what it does is it keeps a parallel version of the DOM in pure JavaScript that's a very lightweight version of the same thing. As you make changes to your, the next render, it can compare its previous virtual DOM to the next virtual DOM and decide, hey, are these things different? And if so, where are they different? And just translating those few things that changed into actual DOM API hits, which inevitably will take some time. But so React also realized that this is not actually enough, because even though you're avoiding the expensiveness of the DOM API, constructing these virtual DOMs and doing this diffing is still takes a decent amount of time, which is why I gave it $2 signs. So there is a lifecycle hook called should-component-update, which pretty much lets you decide if your component even needs to bother doing this whole virtual DOM construction and diffing. This is where the really good practice of thinking about your render method being pure, meaning that it's only dependent on props and state. If you adhere to this very simple philosophy of immutable props and state and only using those in your render method, you get this really nice property that says, if none of the props have changed and none of the state has changed, my render should actually always be identical. And you can say with confidence that I can just tell React, don't even bother rendering. And that's where pure render mixin comes in. It really just implements this should-component-update method, which is these two shallow equals comparing props and state. There are a few other flavors of this now. I think in React 15, it's pure component, and there's some other things. I'm not really familiar with that. So now let's look at the fundamental issue when dealing with performance issues. You know, you're using Flux or Redux or whatever. You have the store. Your store data goes into your root level component. Your root level component is broken into subcomponents that are logically separated because it's easier to deal with the complexity with multiple views. So you've got this big, clean mess. And what happens is you're trying to modify one component, this view in the corner here. Typically, what happens in an app is when a component tries to trigger some action that updates state, usually it's that component itself that is going to be re-rendering. It's not going to be hitting that view that causes some other view on the page to update. Usually it's fairly localized that a view only cares about its own concept of props and state. So the issue arises here is when we trigger the view, the action goes to the dispatcher, which goes to the store, which hits the top level view, which has to re-render all its children, and all of its children have to re-render. And we're going to hit the virtual DOM comparison performance hit, where we're getting a bunch of these yellow dollar signs, which should be unnecessary, because really all that we really need to happen is the three red dollar signs. So really the fundamental fix here is utilizing that pure render mixin. we can turn some of these views into pure views by mixing that in or writing a should component update that looks like that. Hello? And now you'll see here, when the pure view triggers the action, only the views that actually need to change are re-rendering, and then everything else is able to short circuit and get the smaller performance hit of just computing the should component update. And you'll see, if you look at the unoptimized versus optimized, it's drastically better. You can't actually translate these directly to numbers because they are sort of relative depending on how complex each of these components are, but in general, you're going to get a lot of performance benefits from doing it this way. Now that we have a sense of our requirements of, oops, that's weird. Cool, okay, so next I'm going to talk about the perf tools at your disposal to sort of identify these performance areas that need fixing and how we actually go about fixing them. So Chrome DevTools is really great. Honestly, I imagine Safari and Firefox also have great dev tools. I just don't use them, so sorry if you use either of those browsers. I'm only going to use Chrome for now. So I'm going to switch back into our application and bring up the inspector. And it's sort of this hidden, sometimes you hit escape and you bring up the second pane, which has rendering. Sometimes it's hidden here. It's very hard to navigate. And there's this thing called an FPS meter. And this provides a very crude way of tracking how performing your application is. You'll note that it's not moving at all right now, and I think that might be surprising at first, but really it lets you know how many frames are actually rendered, and if you're not doing anything, there's nothing to render, so it just stays put. If I start scrolling, you'll see, oh, look at that, the free 60 frames per second. I didn't do anything for that. So next, what'll typically happen is I'm testing performance. I'm going to just try typing in here, just to illustrate a point. If I try typing in here like this, how are you doing? You'll notice I'm getting abysmal performance. This is actually a thing that I noticed is that the elements pane is also using the DOM, and it also needs to re-render. So you actually sometimes conflate your performance with just the Chrome DevTools being open. If I switch away and perform the same thing, you see you get way faster performance, just an FYI. Next is Chrome's DevTools profiler. Now this is a general all-tool purpose thing that works for any application you're developing. If you're ever having slow JavaScript, you can just use the JavaScript profiler. Even if you're having slow CSS, there's also a timeline profiler, which shows you pretty much everything that's going on when in each of these frames and figuring out why it's slow. When you try using Chrome DevTools profiler, you'll often run into this stupid thing where you'll see the slowest thing is validate. And this is because in React's development mode, it does prop type checking. And prop type checking can be very slow, especially if you have these fancy prop type checks, like for a table, it's an array of these objects that have a text and a value field. So what I like to do is actually, how do I get out of this? I like to actually use production build when doing perf analysis. You get pretty much the same experience you expect in production in your dev environment. And that's really what you want to be testing, not this slower version, because you really just don't know what's going on. The next tool, sorry, and one other thing, so after you turn this off, if your application if there is no single JavaScript function that seems to be causing a performance hit, often it'll be because you're trying to render too many components. And that's where React's code is actually going to end up being the bottleneck. And it's really hard to reason about the profile because it just says, oh, batch updates took all the time in the world. And you're like, what the hell does that mean? Which is why React built a set of tools called react-addons-perf, which does more component-based analysis of how your renders are going. It has a very simple interface, perf.start to start recording, perf.stop to stop recording, and then there are a few print operations print actions you can do: print operations, print wasted, print inclusive, print exclusive. I'm only going to talk about two of them because I think the other two aren't as useful. The first being print operations. This actually shows where React is touching the DOM, which is ultimately the set of changes you expect to happen when your component updates. Print wasted are all the times that your component did the virtual DOM diffing and realized there actually is nothing to update. And the nice thing about this is these are literally all the places that you could add in pure render mixin and avoid the performance hit from print wasted. Another thing to note here is that these perf tools only work in the development build, so we are sort of at this weird situation where we want the fast behavior of production mode, but the perf tools of development mode. And it actually turns out you can just go into React and change the React perf to ignore the build type and then just use production build. I found that it actually works pretty good. So the next couple tools are homegrown solutions that I found have helped me debug faster. I highly encourage you to, if you ever see yourself doing something very repetitive, like why don't I just build myself a quick little tool that solves my problem? In my case, I built this little red button. If you click it, it starts perf.start. If you click it again, it does perf.stop and calls print wasted. I also added a new thing where when you hit the Alt key, it toggles it on and off, so you can do these quick recordings by just hitting Alt, dragging, hitting Alt, and seeing how your performance was. I've also posted the code on a gist, so if you want to check that out, feel free to adapt it. Sorry, it's in CoffeeScript. You can deal with that. Second tool is why did you update mixin? It does exactly what you think it does. If you mix this into your component, if your component updates, it'll tell you exactly why that component updated. And so the case that this is useful is you have these things that are wasting time, and you want to figure out why are you re-rendering when really your props should be the same. You drop this into that component, and when you try interacting with it, you'll get the summary as seen here of things that will hint to you why your component was re-rendering. I'll get to that in a little bit more detail in a sec. So now using these tools, I'm going to show you a workflow that I personally use that makes it really easy for me to figure out why my components are rendering slowly. And then go over some other tools that some other strategies that aren't as simple as just throwing this magical pure render mixin in. So ultimately, the problem with what you optimize are the bottlenecks. These are the slow components that are taking up the most time. And it's really the same process across all software development. You have the slow behavior, you run some profiling code, you trigger the slow behavior, and now you've identified this thing that's bad, and then you do some debugging into that one component, you fix it up, and you're good to go. In the React land, we're going to use the react-addons-perf to identify the bad things. We're going to use why did you update mixin to debug, and finally pure render mixin to make our component good. So let's check out a local version of my benchling that got bad. So I've got this really long entry. And scientists are going to have way longer entries because they just like typing a lot of stuff. So I like my notes. Oh, that's fast. No, it's slow. There it is. So this could be faster, right? It's lagging. I don't know if you can tell. If you look at the frames per second, that could have been better. So we go, OK, why is my thing so bad? I'm going to switch to my code. Let's throw in this perf button attach a DOM. Again, sorry for the CoffeeScript. We're still migrating to ES6. Deal with it. I throw in this record perf button. And because it's in the module, it's probably not going to hot reload. So I'm going to do a full page refresh. Boop, 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 boop. Doo, 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 doo. And there it is, our magical perf recording button. So now what I'm going to do is perform the same action that I know to be slow after hitting the Alt key, which will turn it on. How are you doing? Why are you so slow? Why? I can hit Alt key to stop, and boom, we get this really nifty table. And we see something interesting. We've got these two components that are wasting, or these three components that are wasting a lot of time. So I have a little more context into this application, and I'll tell you that Note Editable has pure render mixin already in it. So it's really surprising that this component is wasting this much time, given that it's supposed to be pure. So what I'm going to do is jump back to my application and go, OK, well, let's debug you. Why did you update? I should have chosen a shorter name. And now some magic hot reloading. Ooh, it already, okay, so I think that's probably just from the reloader. I'm gonna try, oh God. It can be a little noisy. Okay, so I'm doing all this stuff and okay, so we notice that this thing is saying that our update handler is avoidable. And what this is, what my tool does is says if it sees that you're passing a function in to a component and it's seeing another function that's not the same as it, it's often the case that you're using function.bind. And I don't know if you know this, but function.bind always returns a new function. So in your React component, if you're doing, oh, I have a list of items, so I'm going to do update item.bind null index, every time you render that component, it's really going to be a new function, and you can't utilize pure render mixin. So this looks exactly like what's happening. So let's go look at our code. And we'll see, oh, look at this. There's a bunch of these methods that sort of solve this problem by doing the binding inside the component to avoid passing in a bound function. What we'll notice is that the update handler is, where is it? Being used directly. That's sketchy. So let's look at where our usage is. And we go, oh crap, we're doing the bad thing that we shouldn't be doing. So simple fix is don't pass in a bound function. Let the component handle it itself. So I'm just going to, you'll notice that this seems a little repetitive and doesn't seem like a scalable way of writing a component, which is why I'm going to cover some things near the end of my talk of how to deal with this sort of unscalable solution. So now we have this method. Instead of using props at update handler, we're going to use our bound version. Jump back to our application. Jesus. At some point, we're going to have some hot reloading going on. Did it happen? I guess I can turn off. The hypothesis is that I fixed it, so I'm just going to be a little cocky here. And go back. OK, how fast is this? Wow. Cool. And I'm getting my 12 frames per second that I can only type at. And just to clarify, let's double check. There might be some things here, but OK, there's still some things that we can probably room for improvement. But if it's not actually causing a degradation in performance, it's OK that your code takes a little bit of time. Boom. So we solved that issue pretty quickly. How do I get back to? There we go. All right, but now that solves a general class of problems. But sometimes you throw in all these pure render mixins, and you're still going to run into some issues. It's often a solution that works, but sometimes you have to think about how you're passing data around to do it a little smartly. So for the few examples, I'm going to look at our table component, which can be like 50 rows by 30 columns. That's a lot of DOM nodes. And it's a lot of components. And if you're not doing anything smart about it, you're going to end up running into this issue where even with the pure render mixin, you're still doing this minimal check across all these things, and it takes time. So the first trick is using state deliberately. Now, a lot of the times you'll hear, oh, I need to move all my state into my store. All my UI state just goes in my Redux store, or whatever, blah, blah, blah. That might maybe help with having a clean separation of stuff. But at the end of the day, it's sort of weird because this cell resizer, we're trying to resize this one thing. It is the only component in the world that cares about that value. So it doesn't make sense to hoist it all the way up where no one will actually ever use the value. And in doing so, you're going to have that whole annoying problem I had earlier with all those yellow cells rendering for no reason. If instead we have this tight loop where the view just tells itself, hey, here's my new state, re-render, we see that it just updates. And the only performance hit we have are the $3 signs for that component updating, which is the best we'll get. Another similar issue is now we're typing into a table cell, and we also want to show the value inside the formula bar at the top. So the natural thing to say is, oh, well, if these two components have shared state, let's just put it in the logical place is the least common ancestor of these two components. In this case, that would be the table. Again, we have the same issue where if we treat the table component as this monster of a component that ends up having performance issues, we don't want to have to deal with optimizing that component when really we just have these two isolated components that want to share value between each other. And a simple solution is letting them both directly listen to the store. So now we have these two formula editable components that are directly listening to the store. When one updates, both of them are going to get the information, and they're both going to update really quickly. What that looks like in our original diagram is this sort of shortcut. Instead of going through this bad path of everyone hearing about it and having it trickle down the same bad thing, we call a different action that only the formula store responds to, and only these two formula editables are listening to. And again, we hit our ideal performance where only the components that need to know about the update are actually getting it. One other strategy, is just render less stuff. If you have O of n data, you're going to have O of n problems. If you have, you're only rendering 10 things, worst case, you're rendering 10 things. Even if you figure out ways to optimize things, I found that there are always going to be things that are going to cause problems, especially in the browser. I recently found a Chrome 52 accessibility bug where if you have accessibility on and you have a lot of DOM nodes, it just goes to crap. And there's really nothing you can do about it if they're using a screen reader and your site happens to use a lot of DOM nodes. Similarly, there are CSS issues that I found with tables where you're trying to make the table's cells fill the entire space, and it ends up just crapping out because of the sheer number of DOM nodes inside your table. So there are a few options of dealing with showing less data. Three that come to mind are infinite scrolling. There have been works, and other people have done this. There's Flipboard made React Canvas. A little sketchy because they're not using the DOM anymore, but if it works, it works. Facebook also released fixed data table, which lets you formally render like tens of thousands of rows if that suits you. But keep in mind that there are problems with this. Typically, these sorts of things need to assume that there's a fixed height for each of your components. You'll notice in our implementation of it in our sequence map is that the scroll bar actually changes size because we're actually just showing proportionally how many bases you're seeing, not how much vertical height you're actually rendering. Yep. The two other really simple solutions is paginate. You just have an X button. There isn't really that big of a performance hit from hitting X because it's not a continuous action the users are performing like scrolling. And also, if you have collapsible sections, for us, we actually have your entries are separated by days. So logically, we can collapse days, and we don't have to worry about the performance hit having a lot of data. If these sorts of tips were pretty interesting to you, I highly recommend you check out my 2 blog posts on how to do performance engineering React. I go into a little more detail and cover some more tips. Now on to the final bit is how do you prevent and detect these regressions? So at Benchling, we ran into a couple of incidences where a small change resulted in a huge performance regression. And this affected real customers. They're using the site, and it's just getting really bad. And we didn't catch it in our testing phase before deploying to production. So we realized we needed a better way to detect and prevent them instead of waiting for users to complain to us. Our first thought was to write a test that ensures that a key press triggers a re-render that spans no more than 30 milliseconds. This isn't really a great idea because if you've written tests like this, you'll realize that it's super dependent on your hardware and how isolated your test is, and you'll run into issues like this where a test that was once fast, I don't know if you can see this, it used to take less than 750 milliseconds, now takes more than around 2 seconds. And then as we changed our building environment even more, it took more than 3 seconds, at which point a test saying this is fast really didn't make any more sense. So we ended up skipping the test entirely. But there are better things that still capture the essence of this test, and that's you want to capture time, but in a way that is deterministic, that's sort of independent of CPU and other factors like memory. And you're looking for these proxies, which should be deterministic and proportional to time. And interestingly, these two things are things that React provides for you. That's print operations, which tells you the number of DOM operations that React is performing, and print wasted, which tells you the number of components that are rendered without change. And often, these are the two things that you actually really care about. When I'm typing an edit, I expect there to be very little things wasted. And when I make an edit to one cell, I expect one DOM operation. That's the changing of the text of that one component. Now, React doesn't have a solid API for their perf that's stable yet. So we can sort of do this little hacky thing where we mock out console.table. call perf.start, run our function, stop it, and then look at the results of what console.table had. And it works. It's a little hacky, but it works. And we're able to see how many DOM operations happen when doing an operation inside our test. Similarly, we could write one of these that used for print wasted. We'd look at the number of instances that updated of the type we care about. I don't have a sample here for you, but you can at least see this gist that shows that you can get access to this code. And the way this test that I wrote works is we render an editor with 5 components, we do an edit, and then we do the same test with like 100 items and do that same edit. We actually expect there to be the same number of DOM operations. This sort of makes the test a little more flexible instead of dealing with the fact that maybe we still do a constant number of operations in both, and our test doesn't just break sporadically for that reason. But as great as tests are, it's always better, I think, to not have to think about these tests and just have better abstractions. React provides a lot of nice ideas that make things better without you even having to thinking about it, right? You don't have to think about accidentally touching the DOM and then reading from the DOM and then setting in the DOM and causing these reflows. Reflows are really a thing of the past if you're using this declarative syntax. Similarly, when you're writing your React components, you can write them in a way that makes them reusable, makes them avoid hide the ugly parts of your performance hacking. So I'm going to cover 3 components that we built that we use at Benchling. First is our editable component. It's sort of the core to all of our editable content on our site. It does fancy things like caching the HTML that's going to be rendered into it. It makes the content editable, actually usable in React. I think in the Draft.js talk, when they first announced it, they talked about how they did that as well. And it's sort of an ugly abstraction, but it's consolidated into a single component, so we can reuse it everywhere. And when the time comes, we want to really just double down and make it better. We have to touch one component, and it'll be better. The next one is something I call intermediate binder. It gets around the problem of wanting to have you have a list of items, and each one wants to have a method that is specific to it. You want to bind the index to bind the ID or the index of your item in the context of your list. And the issue is using bind is that, again, you get this issue where you can't use pure render mixin anymore. The common solution is rewrite your component, have it taken the unbound function, have it taken in the index, and then manually do that bind, as you saw in my other component. A sort of hacky temporary fix to quickly fix the issue without having to do too much is making this sort of interesting component that takes in methods that you want to bind, an argument that you want to be bound, and it sort of does this magical thing in its should component. When it receives props, it does a check to see if the bound arg changed, and only in that case does it create the new bound function. So now when you actually expose it, we use this interesting pattern where the children is actually a function, and you can pass it information. These bound methods are actually going to be the same across renders if the index hasn't changed. So now we can change our expensive component into a pure expensive component, and it'll get these bound methods that are going to be the same across renders. It's a quick, dirty solution that solves the perf issue. But I think ultimately the better solution is when you have this sort of list of items, and you want to have a better abstraction to prevent, like in our application, we have tables right now, we'll have images, maybe we'll add a new thing, I don't know, something else. And when you add that component, you don't want to have the developer to have to remember, oh, I need to stick pure render mixin into this because this is a hot code path that needs to be fast. Instead, we can sort of create this wrapper item component around each of our items that has a switch statement that renders each of the components, and the interface is fairly fixed. It takes in the type of component, it takes in the actual item data, a unique identifier, and then maybe an object of all the actions that you could possibly want to pass to a subcomponent. With an interface like this, it's very hard to accidentally introduce a prop-derived. All props are non-derived, so that means you're not going to accidentally introduce a newly computed thing that's going to break your item from re-rendering correctly. Also, I guess a small thing, using a UID instead of an index is actually pretty important. If you expect users to hit enter near the top of your list of items, every time you hit enter at the top, your indexes are shifting, and you're going to cause some interesting things to happen where all of your components need to re-render because their indices are changing. And now to actually detect regressions, because that's going to happen, as good as your abstractions are, you're going to miss some edge case where somehow things are going to go bad. And a few observations that I've taken from having this product deployed for a while is that the experience you have in your development environment often is not the same as your user's experience in the prod environment. Often this is the case because your customers actually have real data, and they don't have this really crappy fake data that you saw in my, where is it? You saw my fake data. It was pretty bad. It was literally just the same text over and over again. And so the thing is, our actual users will have a variety of tables. Maybe they'll have 100 tables. And that's something that isn't often foreseen, because why would you have 100 tables in one document? You should have multiple documents. So that they're pushing the boundaries of what you expect reasonable. And the worst thing is, a lot of the times users will just suck it up and say, the software works, it's a little slow. And a lot of users will just sort of hate you secretly, just a resentment that builds up as they're using your application. Eventually, they get pissed and they start yelling at you via your support channel. So the solution is not to wait for them to complain, but actually add monitoring. And the idea is simple, and you take your code path, and that's like hitting a keystroke, and you use some performance metrics to keep track of how that's going. So we just recently added this really simple thing. Can I zoom in? All it does is you call it before you actually do your store update, and we're measuring the time at a certain mark, waiting for the next frame by using _.defer, same as set timeout 0, and then measuring the new time. And the difference between those two times tells you roughly about how long that action took to actually fully finish. We can then log this with other data, metadata like how many tables they had, how many lines were in their file, what build they were on in case it's a regression. And now we can do fancy things like throw this on a dashboard, have alerts set up like, oh, this new build seems to have the average FPS drop, or the number of milliseconds drop or increase by a lot. So in conclusion, the things that I've learned is that it's very easy to introduce regressions. Don't accidentally lose your highly tuned performance optimizations by not having tests and not having better abstractions. It's important to have a sense of how your users are using your product. Even if you do user interviews or just collect metrics on how they'll be using the product, you'll have a better sense of what you expect from a performance aspect. And lastly, building things from scratch is hard. We built our product in 2014. There was no implementation of Flux. We really read the docs and read the white paper. I was like, OK, let's build this dispatcher thing, whatever, and do all the things. There was no draft.js that solved a lot of these problems. We sort of had to build from scratch. But now that it's been out for so long, I highly recommend that you utilize the community-driven components and ideas, and you'll save yourself a lot of headache. Thank you for bearing with me through that. You all were perfect. Thanks for listening. Here's my Twitter and website. If you've ever played the escape.alpha.new game, there's a quick way to get alert 1 for you there. Thank you.